In the previous section of the final, we discussed how to calculate the slope, and there were several different methods of doing that. They were all giving you the same answer. You could use the graphical method to figure out the distance from left to right by drawing a slope triangle. You could use a formula to find the distance left to right by figuring out how to subtract the two numbers. You could use the symbol delta to represent the change between two numbers. And then lastly, there's a possibility that you have an interval that is not 1. So those were what we discussed when we talked about how to find the slope. Now, you can use the slope to write equations that allow you to make a prediction. For example, in this situation it says, Alex is buying pizzas. Each pizza is $10 and delivery is $5. I'm going to highlight this word each because when I see the word each, every, or per, it tells me that I am seeing a rate or a slope. Each pizza is $10 and delivery is $5. So this is a different kind of a cost. This kind of a cost, a delivery cost, you only have to pay one time. So what happens is that the pizza guy comes, and no matter how many pizzas that you've bought, he just comes and he has his whole stack of pizzas. So maybe you bought 4 pizzas, so you had to pay for those 4 pizzas, but you only paid for delivery once because he brings them to you all at once. So one of these is a cost that you pay each time, and one of them is a cost that you only pay once. I'm going to close the door. And then it says, write a function, in other words, an equation, for how many pizzas you can buy for $75. So I need to very quickly summarize what my variables are here. Okay, write a function for how many pizzas you can buy for $75. So each pizza is $10. Okay, so I'm going to put n to be the number of pizzas, And then my function f of x is going to be returning, let's say, c, the cost of the pizzas. Okay, so I'm going to put the number of pizzas in, and the more pizzas I buy, the more it's going to cost. Okay, so let's write our function. It's going to be $10 per pizza, so $10 times the number of pizzas. So for example, how much would 2 pizzas cost? Well, that would be 10 times 2 would be $20 because each pizza is $10. And then 3 pizzas would be $30, 10 times 3. And then plus the delivery cost. So 10 times the number of pizzas plus the delivery cost. Now remember that you only pay the delivery cost once. So you don't have to multiply the delivery cost. You multiply the pizzas. 10 times the number of pizzas, not 10 times the delivery cost. Equals the cost of the pizzas, and the cost of the pizzas, the output here, the cost of the pizzas is $75. Okay, and that's it. So it's 10 times the number of pizzas plus $5. Let's just pretend that I hadn't done any of that. So let's just pretend that I hadn't talked to you about the equation of this at all. You know that if each pizza was $10 and delivery is $5, you know how many pizzas you can buy for $75. So it would be $5 once for the delivery, and then 10 for a pizza, 10 for a pizza, 10 for a pizza. Okay, that's $35. 10 for a pizza, 10 for a pizza. So that's 5 pizzas for $55. 65, 10, 20, 30, 40, 50, 60, $75. So I could buy 7 pizzas for $75. So before I did anything, you should have known that the answer was going to be 7. All right, so let's use algebra to prove that. So the opposite of plus 5 is minus 5. So excluding the delivery cost, the amount of money that I have just to buy the pizzas is $70. So because I have to save $5 for the delivery cost, I need I only have $70 to buy the pizzas. And then the opposite of times 10 is divide by 10. And then 70 or 10 into 70 gives me 7 pizzas. which makes perfect sense because 7 times 10 for $10 each plus 5 for delivery gives me $75 out. And then the last thing that I want to do is notice that these two quantities, we've actually defined them in a new way now. This quantity here, the cost for each pizza, that's how fast the cost of the pizza increases. And so that is the slope. It's telling me how fast the cost goes up when I order more pizzas. And this second quantity here is the y-intercept, because it's the quantity that tells me how expensive it was to order the pizzas, even if I ordered 0 pizzas. So in other words, if n was 0, then the term that was left over was $5 to start with. Okay, so that's the y-intercept, because 0 pizzas still cost you $5 to deliver. Now the letters that I use for that are m here, so that's m times the number of pizzas, plus the y-intercept, I use the letter b. Okay, so the function was 10 times the number of pizzas plus 5 equals 75. Let's use that to make some other calculations. For the equation y equals 30 plus 15x, what was the slope? Well, we just learned that the form of our equation is y equals mx plus b, where m is the slope, and where b, let's use blue for b, of course, where b is the intercept. Okay, so m was the slope, and b, whatever you put here, is going to be the intercept, and the y-intercept. And I've kind of tried to trick you here because I put it out of order. Now remember that when we talked about the pizzas, you multiply the number of pizza times the cost of the pizzas because you order the pizzas over and over again. And the thing that you multiplied, which is called the coefficients, that's what the slope was. The thing that you only paid once, the delivery cost, that was the intercept. So even though I've switched the order here, this here is still the coefficient. I'm still paying this amount over and over again, 15 times x. So this is the slope, even though it's out of order. It's multiplying the x, and because of that, it's the slope. And then this thing here, you only pay once, and that's the intercept. Okay, so this would be b plus mx. It's perfectly okay to switch that order. So I'm trying to be a little bit tricky here to see if you understand that the slope is the thing that multiplies the x. All right, so that means that it's not a big deal here. That means that the slope is 15, right? And that the intercept is 30. All right, so the graph of this line would start at 30 and it would go up 15 each time. So if this was 15, 30, 45, 60, 1, 2, 3, 4, then the slope would start, this line would start at 30 here at B, and it would go up 15 every time. So it would go up 15, up 15. Okay, so that would be the shape of the line given by this equation. All right, I've got two more. This one is going to be probably the hardest of the bunch, so I'm going to make a new video to calculate that. It's going to take 2 steps. First I have to use the slope formula, and then I'm going to have to find the intercept, which is here. This one is just going to be the opposite, so I'm going to put mx plus b. I just have to decide which one of these numbers which is m and which one is b. And then the last one I need to sketch. First I need to find m and b, and then I need to show you what b means in terms of a graph. So I'll come back for the second video and I'll do those last 3 problems.